Ever wondered how your GPS knows exactly where you are? Or how skateboard ramps, roads, and roller coasters all have the perfect angle? Well, it's all about this one thing: slope, the secret language of lines that tells us how steep or flat something really is. Welcome to Module 8, the coordinate plane and slope. Today, we'll explore how to plot points, find slopes, and unlock the geometry behind motion, design, and direction. By the end, you'll know how to plot points like a pro, spot parallel and perpendicular lines instantly, and calculate the slope even from a real-world examples. So grab your pen and paper, get ready to rise and run, and let's make math come alive, right here in Module 8. Hello everybody, hope you're doing well. My name is Mahmoud Jasari and welcome to the new module of Algebra 101. So today we are trying to talk about the coordinate plane and slope. As I just told you and as I just mentioned, for the previous chapters we were talking a little bit about that, about the lines, about how we can some kind of draw them, but I didn't talk about it in detail. So in this chapter and in this module, we are trying to be in detail and see that when we are drawing a line, what does that mean? So what is the difference between one specific line and another line? How we can find the points, how we can connect them, and so on and so forth. So without further ado, let's dive in. So again, we are at this point, we do have a couple of objectives. We are trying to plot ordered pairs on a coordinate plane. I will talk about it, what is a coordinate plane. We are trying to find the slope from 2 points or graph, and we are a little bit talking about the parallel or perpendicular slopes, which we know intuitively what does that mean, but we are going to show you in a plane wise. And after that, we are going to interpret the slope as a rate of change with units and have a little bit of real world examples itself. So first thing first, what is the coordinate plane? As you can see over here, I do have two lines. That one is horizontal and goes from left to right, and another one is vertical one and goes from bottom to the top. And these two do have one intersection at this point. So we call the whole thing right now as a coordinate plane, and each coordinate plane has a couple of important things. The first one is about the x-axis, as I just mentioned. The next one is about the y-axis, again I just mentioned. After that, we do have the origin, or we do have the vertex that we call it as 0, 0. I will talk about it, what the 0, 0 means. And after that, we do have the quadrants. What is the quadrants? It means that right now I do have 4 different sections or 4 different quadrants that I named them: 1, 2, 3, and 4 itself. So let's back to the idea. What is the coordinate plane? Why we're using that? So as we all know, in a two-dimensional setting or the two-dimensional environment, each unit has 2 criteria. One is x-axis, means that how some kind of what is the place of that specific point or that specific object is on the horizontal section. It's going to start from the negative side to the positive side. That we call it as the x-axis, or it's going to be the first point of our pair. After that, we do have the y-axis. We would like to see that that specific object or at the specific point is elevated from the ground, is on the top, or is underground. So we are going to use the y-axis and x-axis in order to show an object in the two-dimensional setting. How we can do that? Obviously, we need a playground. That playground is something we call as a coordinate plane. So in each coordinate plane, in each quadrant, we can use them. We do have unlimited option, and it completely depends on our desire and based on our x-axis and y-axis that where we can put that specific point. So let's see a couple of examples over here that I believe it can show you how you can completely understand it, what's going on. Imagine that I would ask you to show me the points 3 and 2. By the way, remember, the first point all the time represent the x-axis, or at least how far you have to go on x-axis, and the second point is the y-axis itself. So at this point I do have 3 and 2. Whenever you don't see any sign beside your number, we know that it's going to be positive, right? So right now I do have 3 and 2. It means that I have to move 3 to the right, which right is my positive, and 2 to the top, which is my positive. To the left would be my negative for x-axis, and to the bottom is going to be negative for my y-axis. So I do have 3 and 2. 3 move to the right. So right now I'm moving to the right 3 points. 1, 2, 3. That is my x-axis. After that, I have to move to the top by 2 steps. 1 step to a step, and that is my point, and I will show it by 3 and 2. As you can see, it's in the first quadrant. Let's see another example. -2 and -1. Again, this is x, this is y. -2 to the left, it would be -1, -2, and -1 to bottom, or 1 step to the bottom. This is specific point. I do have 0 and 4, so it's going to be a little bit challenging because right now you see your x doesn't have any specific number, or it's just 0. It means that I shouldn't at all move over the x-axis. So the only place that I have to move is just y. So I'm going to stay over here, stay at this point as x-axis, and I'm going to only move 4 to the top, that I do have it as 0 and 4. At the end, I do have x and y as -5 and 0. I do have the same scenario like the last one, but with this difference that this time my y is 0. So it would be 5 to the left. It would be 1, 2, 3, 4, 5 to the left, and this would be my point. Again, remember, we have to walk first through the x-axis and then the y-axis. Nobody says that if you don't move through the y-axis first and after that x is going to be something wrong. But here's the issue. When you have a number or a pair of number, the first number is x and the second number is y. So if you are going to move through the y-axis first, you have to make sure you start from the second number, not the first number. So let's move on and let's go a little bit deep down at talking about all of those steps that I had, again using an example. So how we can plot ordered pairs. Again, why we're talking ordered pairs? Because x comes first and y comes next. So at this point, we do have 3 important steps. First of all, start at the origin. What was origin? Origin was 0 and 0, or it was the vertex or the core or the reference of our coordinate plane. After that, we have to use x units or x numbers, or using the x-axis. Right if it is positive and left it is negative, just like the examples that we had. And after that, we have to move y units, y to the top if it was positive, and to the bottom if it was negative. Again, let's see a couple of examples. 4 and -3. As you can see, x is +4, so we have to move 4 to the right, 4 to the right, and after that, -3 or 3 to the bottom. That would be our point. The next example would be -3 and 4. Again, -3 or 3 to the left, and 4 to the top itself. As simple as that. After that, we have to talk about some kind of a very important definition: slope. Obviously, you've heard about that. The slope of the road, slope, I don't know, about something is leaning toward another thing, or any other kind of stuff. So what does actually mean, slope? Slope has a very simple definition. It means that the rise over run, or how fast your y changes when x moves. So we do have a very important formula for that. By the way, this should be like this. It is delta y over rise over run, or delta y over delta x. So what is delta? Actually, maybe you saw delta at a couple of points in probably your math or physics. So delta means the difference. Instead of just showing that, for example, y2 subtracted by y1, we are showing it as delta y. Delta y means that right now you are at a point, after that you're at another point. What is the difference between these 2 points? That would be delta y. So when we are talking about the slope, we are talking about the amount of rise or delta y, why we do have specific delta x. By using that, I can find the slope, or I can see that how is some kind of line or moving backward. So this was the very specific definition about the slope itself. Right now you can see a couple of images. So at the beginning we do have the small positive slope. It means that it's just gentle uphill, rises gradually to the right. We don't have a problem with that. That is good. Next one is a large positive slope. So as you can see, it means that your denominator is way bigger than your denominator. So we do have it as a large positive slope. It means that steep uphill raises sharply to the right. After that, we do have the zero slope. So what does that mean? Imagine that you have only a line. So in this line itself, and this line, I'm trying to align it. So this line itself, just like this, it means that doesn't matter how much I'm moving forward or backward, my y is not changing at all. It means that I do have a zero slope. So the slope definition doesn't mean anything over here. So right now, we do have a flat road, for example, like this third one, like this one. We do have a flat road and no rise as x increases. At the end, we do have one challenging slope that we call it as undefined one. Imagine that you do have this rock and you're trying to find the slope from this to this point. So as you can see over here, despite the fact that x is changing very little or not changing at all, my y is changing so fast. So it means that I do have a line that is moving from bottom to top like the y-axis. So slope doesn't mean anything over here, because if you again find a number for that, that would be a huge number. So we cannot use it, to be honest. The slope is something that is going to help me. We are going to see it in the next slide. That is something that is going to help me to find a specific point. So what is the usage of that specific line that if I cannot change x, because either the x change is so small or not some kind of change at all. So what am I going to use that for? So this is something that we call as undefined most of the time when the slope is so high, or when the slope is something like the y-axis line, we call it as undefined. So right now we talked about 4 different slopes. Again, we do have the gentle one, we do have the large one, we do have the zero, and we do have undefined one.